basically an encoder and a decoder. So if I give you a code, if I give you a code for a channel, there must be some way to encode that code and some way to decode that code. So we're going to have an encoding function f, defined as a mapping from the message set. So there are capital M possible messages to Sx to the n. So this is the set of n-fold vectors of the channel input. So basically, I'm going to take each possible message. Let me just make that explicit. Note M is the number of possible messages. So it's a mapping from the set of possible messages enumerated from 1 to capital M to n-fold vectors of Sx. Secondly, a decoding function G. G is basically the reverse. It's not quite the inverse, because G has to deal with the channel outputs. So G is a mapping from n-fold vectors of Sy. In other words, the channel outputs corresponding to these channel inputs, mapping from n-fold vectors of Sy to the message alphabet 1, 2, and so on up to M, union with a special symbol I'm going to call 0, where 0 represents decoding failure. So in other words, the decoder has the option to give up. The decoder can map from Sy to a valid message, or it can map it to something that's not in the message set, as 0, which is equivalent to the decoder giving up. An example let's say there are 2 possible messages. And let's let the number of symbols I'm going to use equal 4. So, f is a function from 1, 2. Oh, and let's also let Sy be binary, excuse me, Sx be binary, and Sy be binary. And I'm going to leave the probability of y given x abstract for now. But this is a mapping from 1, 2. F is a mapping from 1, 2 to n-fold, 4-fold binary vectors. In particular, I'm going to say f of 1 equals 0, 0, 0, 0, and f of 2 equals 1, 1, 1, 1. This is actually a very simple kind of code called the repetition code. Decoding function, which is a mapping from 0, 1 to the 4th power, Sy, the 4-fold vectors of 4-fold binary vectors, to 0, 1, 2, and I'm going to specify it this way. g of y1, y2, y3, y4, where y1, y2, y3, y4 is in binary vectors with 4 elements. I'm going to let this equal 1. So 1 was transmitted as the all 0 binary vector. So I'm going to say this is 1 if y1 and y4 is majority 0. In other words, if a majority of these elements are 0, I'm going to map this to 1, because it seems likely that if most of these channel outputs are 0, it probably came from the 1. So that would be like, well, there are 16 possibilities, and I'm not going to write all of them out. But that would be things like 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, and so on and so on. Majority 0. I'm going to let this equal 2, so the input message was 2, that led to an encoding of 1, 1, 1, 1. I'm going to let the decoder give me a 2 if I have a majority 1. So that's like 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 1, so on. So if most of the outputs are 0, I'll decode to 2, and I'll declare a decoding failure if the number of 0 is equal to the number of 1. So in that case, it's, in some sense, the channel output is halfway between the two encodings. So I'll assume that I won't be able to determine what's going on. So for instance, if I transmit a 1, then I send 0, 0, 0, 0. And then if at the channel output I observe 0, 0, 1, 0, then that maps back to a 1. On the other hand, if so that's basically 1 error occurred in transmission. If 3 errors occur in transmission, like this, then I'll map to a 2. So that's actually an error that I made. On the other hand, if 2 errors occur in transmission, then I'll map that to a 0 and say I don't really know what happened. Okay, as another, just to end that particular definition, the code book consists of a set of all possible encodings. That is, it's the set consisting of the encoding for message 1, the encoding for message 2, and so on, up to the encoding for message capital M. Sometimes I'm going to give this the symbol capital C for code book. So that's the set of all valid code words that can be transmitted. So in this example, what was my code book? My code book was f of 1 and f of 2. There were only 2 possible messages, which was 0, 0, 0, 0 and 1, 1, 1, 1. So I can be guaranteed that one or the other of those sequences is what was transmitted on the channel.